Hey everyone, and welcome to This Explainer. Today, we're doing something really cool. We're going all the way back to the absolute foundational architecture of computer science. Drawing directly from the principles laid out in elementary programming in C, we're going to explore exactly how code scales up in complexity. We'll trace it from a single atomic command all the way up to the massive software systems that literally run our digital world.
So, let's kick things off with a pretty fundamental question. How do computers actually know what to do? It all starts with a core truth highlighted right in the preface of our source material. It's a known fact that computers make our lives incredibly easy, but here's the kicker. By themselves, they are completely 100% unintelligent. They have absolutely zero common sense. A computer cannot just guess what you want it to do, it has to be strictly and explicitly instructed. It must be programmed. But how does that instruction actually take shape? How do we go from a human idea to a machine taking action?
To unpack all of this, we're going to take a bottom-up approach today. First, we'll look at commands, the smallest unit. Then, programs, which solve specific tasks. Next, we'll scale up to software for integrated problem solving. And finally, we'll pull back to see the big picture.
All right, let's jump right into part 1, commands, the smallest unit.
Okay, let's dive into this. A command, which you might also hear called a statement or an instruction, is literally the absolute smallest unit in a computing system. You can think of it as a single atomic action. When you tell your computer to do one very specific, isolated thing, like say retrieving a number from its memory or displaying a result on your screen, you are issuing a command. It's just a single step. But, as we mentioned, because the computer lacks any intelligence of its own, you can't just toss an instruction at it and expect it to figure out the nuances. For a computer to actually understand and execute these commands, they have to follow incredibly strict rules. Our source material outlines that the instructions given to a computer absolutely must be meaningful and complete. Furthermore, they need to possess 3 very specific traits. They must be sequential, they must be finite, and they must be strictly accurate. You literally cannot be vague. If a command is missing even a tiny piece of data or if it's slightly out of order, the unintelligent computer simply crashes or throws an error. It requires total precision if you want to build these commands into something useful.
Which leads us perfectly into part 2, programs, solving specific tasks.
So, what happens when you string those perfectly accurate commands together? Well, you get a program. A program is simply a set of those commands, or statements, linked together to solve a problem or perform a specific task. Think of it like this. If a command is a single ingredient, the program is the complete recipe. In fact, our source notes that a set of steps to arrive at a solution is called an algorithm, which is defined literally as a procedure, formula, or recipe for solving a problem. When we write that algorithm out using our highly exact commands, boom, we get a program. And this brilliantly illustrates the concept in action. The text gives us a great, concrete example of a simple program designed to add 2 numbers. Let's look at the sequence. Step 1, receive the 2 numbers. So perhaps storing them in the computer's memory. Step 2, add them together. Step 3, display the result. Each one of those numbered steps represents an individual command, but when they are linked together in this exact, finite sequential order, they form a unified program that actually achieves a real goal. It perfectly solves the specific task of addition.
Now, let's zoom out even further for part 3, software, integrated problem solving. So, what happens when the problem you're trying to solve is just massive? What if you want to run an entire graphic design suite, or connect to the internet, or manage a gigantic database? Well, when a task is just too large or complex, it cannot possibly be contained within a single program. Think about it. A single program might handle saving a file, right? But it can't handle saving that file, rendering 3D graphics, and playing audio all at the exact same time. The task needs to be broken down into several different programs. The crucial point here is this. When all those individual programs are finally integrated to work collaboratively together, that integrated set of programs is known as software. Software is basically the giant umbrella that holds all those smaller problem solvers together. To really put that into perspective, our source gives us an incredibly relatable, real-world example, your computer's operating system. Think about the exact moment you press the power button on your machine. The computer automatically processes a massive amount of information just to give you a functional screen. The operating system, which is a type of system software, exists inside the computer to handle all of this. It performs initial settings, it manages the computer's memory, and it gives you a user interface. To pull all of that off, the operating system relies on an immense set of separate programs working seamlessly together. All right, that brings us to part 4, the big picture. Now, what's really interesting about this slide is how it perfectly maps out the entire hierarchy. This is a direct diagram from our source material. At the very bottom level, you have individual commands. These are those hyper-accurate, sequential, meaningful instructions we talked about. When you group a set of those commands together, moving one level up, they form a program, like Program 1 or Program 2 shown here. Each program solves one specific task. Finally, at the very top of the pyramid, when you integrate Program 1 and Program 2 to tackle a really large, complex challenge, you create software. It is just a perfect, logical progression of scale and complexity.
At the end of the day, every single piece of technology we use, no matter how breathtakingly complex it seems, is really just a towering structure built out of the tiniest, simplest commands. By understanding this relationship, how commands build programs and how programs build software, you kind of demystify the whole magic of computing, doesn't it? So, knowing this hierarchy, what massive problems could you solve by mastering the smallest command? Thank you so much for joining me for this explainer, and definitely keep exploring the incredible world of programming.